Welcome back. So much fun. Here we are trying to use the derivative to find a tangent line at a point. Find the equation of a tangent line to a function through a point. An equation of a tangent line, because remember, we are studying functions that change. They change a lot. They curve and they're harder to deal with than just lines. So if we can make lines, which are so much easier, that relate to the function, then we're going to be able to do a lot more to see what a function's doing and to have it help us anytime we're trying to find an equation of any line, tangent, not tangent, whatever. What are the two things that we need? Yes, a point and a slope. Well, we know how to find points. Those are x, y, ordered pairs, plug and chug. You know how to find points. What we learned recently is how to find slope of a tangent line. That's our derivative at a particular point. Let's look at some practice problems from an AP exam number 1. Let f be this function. Find an equation of the line tangent to the graph at the point where x equals -1. Well, remember the two things we need. First, we need a point. We have part of the point. We have the x value. How do we find the y? That's right. Plug it in. Plug it into that function that we're given. So that's what I'm doing here. Let's plug it into that function. Evaluate that, get our point. That looks like the y value is 4. So we know that our point is -1, 4. What else do we need? Yep, slope. And how do we find slope? You're right, derivative. So f prime of x, let's find the derivative. Here's the function, multiply by 3. Let's use our power rule, 12x squared minus 5. 5, that's it, constant 0, so that's it. Now we specifically want the slope at that x value that we're observing, f prime of -1. Now we just plug in the -1. Evaluate that. Looks like we get 7, so our slope is 7. Well, now what do? We've got a point, we've got a slope. Use point slope form, and let's make a note of that up here. Use point slope form. It's easier, it's faster, you don't have to simplify, and you're done. Quick, easy, done. Y minus y sub 1 equals m times x minus x sub 1. Know it, learn it if you don't know it. Let's write our answer over here. Y minus, the y coordinate says 4, so 4 equals, the slope says 7, so 7. X minus the -1 makes +1. There we are, beautiful, done. Next one. We are going to need a calculator for this one. Do you have your calculator handy? If you don't, go grab it real fast. Find equation of the line tangent to the graph. So equation of the line again. So again, we want to think, what are the two things we need? We need a point, we need a slope. Did they give us any of that? Function at the point where f prime equals 1. I see derivative. Derivative tells me slope. So what I know is that the slope is 1. I don't have a point. So we're going to have to use the fact that the derivative equals 1 to find our point. So let's do that. F prime of x is 4x cubed plus 4x. We want the derivative to equal 1, so set that equal to 1. Now, we can solve a lot of equations that look like this. 4x cubed plus 4x equals 1. This one we need a calculator to help us solve. Here's one way to do it. Bring over the 1 by subtracting so that your expression equals 0. Let's go ahead and use our calculator and plug everything that equals 0, all of that, into y equals, and then we can find the zeros on the calculator. If you don't know how to do that, watch carefully. We'll do it together. Here's my calculator so you can watch as I go. I'm going to go to y equals, and I'm going to plug in, let's make sure we can see clearly, that expression is 4x to the third, and this can be done with any graphing calculator. If you don't have a graphing calculator, maybe you download the app on your smartphone. The location for that, the suggestion for which one is on a link on my school website, not the Vision course, but the CMS course. So here I've plugged it into y equals. I'd like to look at a graph, but I like to do zoom standard to start. So 6, zoom 6. So we get a standard picture right there, and it's graphing it right there. So I can see um, the zeros right around there. So how do we do that? Calculate the zero thing. Calculate in blue right there. So I'm going to do the blue button second, calculate button. There it is, second choice. So go down to 0. It's like that. Now it's asked for left bound. That means be to the left of the 0. So go to the left, press enter. Now I need to cross over the 0 or the x-intercept just a little bit for right bound. Press enter. And I'm going to need to press enter one more time because right now it's guessing. I don't want to guess. I want it to be exact. And it has calculated it to be 0.2367 something something something. In this class, we have to remember that we are using at least 3 digits past the decimal place. Okay, I'm going to move this over just a bit so that we can see a little bit more over here, and I can write. So we have 0.237 if we round that. So from the calculator, I got 0.237. So the x is approximately let's write it as 0.237. There's our x coordinate. Once we have the x, you remember how we find the y? That's right, plug it in, 0.237 plugged in. Going back to our calculator, that gives us approximately 0.115. You can just plug that in to our function to get that y value. Now that we have a point, we have a slope. Let's write our equation. Y minus the y coordinate equals our slope times x minus the x coordinate. Don't worry about simplifying. We're done. Look at number 3. Also from an AP exam. If the line tangent to the graph of the function at the point 1,7 also passes through this other point, then what does f prime of 1 equal? So it's tangent at this point 1,7, and we're looking for the derivative at 1. This is asking the derivative at 1 or the slope at x equals 1. Well, we don't have a function to take a derivative, but they said that this line passes through this point and this point. How did we used to find slope given 2 points? You got it. y2 minus y1 over x2 minus x1. Let's do it here. 7 minus negative 2 over 1 minus negative 2, or do it the other way if you want to. Either way, 9 divided by 3 or 3. Piece of cake once you know what derivative means. Number 4, find the points where this function has a horizontal tangent. Picture to yourself what that means. Here's a horizontal line. Tell me what you know about it. That's right, the slope is 0. Well, what's our code word for slope or our synonym for slope? You got it, derivative, f prime equals 0. So what are we going to do with this function? You're so smart. Take the derivative, f prime of x. Let's use our shortcuts, 3x squared plus 4x minus 15, constant goes to 0. Our derivative has to equal 0, so guess what we're going to do with this? Equals 0. This one we can factor, 3x minus 5 times x plus 3. Set each of our factors equal to 0. And solve. We get 5/3 and negative 3. Now it does ask for the points, not just the x values, so we will need to take this a step further and find f of 5/3, where we plug it into the original equation to get the y. That is negative 22/27, and we'll need to find f of negative 3, again plugging into the original, and that gives us 50. So really our answers have to be a little bit more involved when it says the points and not just the x values. Our final answer should be ordered pairs for points, 5/3, negative 2/27, and negative 350. Last but not least, from a free response AP question. H is a function defined for all x not equal to 0, and the derivative is given. The derivative is given to us. H prime is given. Find all values of x where the graph of h has a horizontal tangent. Again, horizontal tangent. Remember what that means? The slope is 0, or synonym, derivative is 0. Fortunately, they only ask for values of x. So just finding the values of x and that's it. Derivative equals 0. Well, they gave us the derivative, so let's use that derivative. X squared minus 2 over x has to equal 0. When a fraction is 0, only the top needs to be 0. Where does x squared equals 2? That's right, at plus or minus the square root of 2. And they just said, find the values of x. We are done.